Hello guys, welcome to my channel Techmon.in. In this video we will learn how to create our own functions, that is user defined functions, and use them in Pyspark. So we will I've already imported the required libraries. Basically we will be needing types to define what kind of the our data type of the output variable, and also we will be requiring UDF, which resides in functions. I've already created Spark session here and loaded the dataset, which is iris dataset. So as you can see here, iris dataset have 5 columns, 4 of which are numerical, which are sepal length, sepal width, petal length, and petal width, and 5th column it is a class label, right? So also it contains 150 records, uh, 50 for each of the class label. So it has 3 class label: iris setosa, iris virginica, and iris versicolor. So let me also show them to you. So we will just select this column class, take distinct of this, and then just display the results. Okay, so what we are going to do in the meanwhile it is running, so what we will do here, we are going to convert this class label, which is of type category text, right? We will convert this into numeric value. So as you can see here, we have 3 distinct values inside this column. So what we are going to do, we are going to convert these into numerical. How we are going to do that? We will create few columns. So let's take 3 for now. So we will create one for setosa, one for virginica, and third one will be for iris versicolor. Okay, so as you can see in these records, let's take first record. The class label is iris setosa. What we'll do in new column, the value under setosa column we will put 1, while in rest of them we will put 0. Okay, but for example, in another record, virginica was true, and other rest was 0 by default. So what we'll do, we'll put 0 under setosa, 1 in virginica, and 0 in versicolor. Similarly, in third case, if we had class label as versicolor, we'll keep setosa 0, virginica 0, and versicolor as 1. Okay, so this is how we will convert our class labels category type data into numerical values. But here there is one catch. As you can see here, we are required required to create n columns for n class labels. But as you can see, if we remove the third column, let's say this never existed. So now let's interpret the results. So when this is 1 0, this indicates that setosa is true for a particular record. The class label is setosa and not virginica. In second case, what we are telling, or what this indicates, is setosa is false and virginica is true, right? Basically this record belongs to virginica class. In third case, it is neither setosa and neither virginica, right? So automatically, since we already know we only have 3 class label, so this third set of value 0 0 will represent to our versicolor, right? So that's why, for if we have n distinct class values, we will only require n-1 columns to represent them. So in our case, we had 3 columns here, 3 distinct class labels here. So that's why with only 2 columns, we'll be able to represent all these 3 values. So now what we are going to do, we are going to create our own Python function UDF to convert these values into one hot encode these into this format and use it in Pyspark. So let me start here now. So def one hot encode, I'm going to write normal Python function first, and then we'll see how we will convert it into Pyspark function, which is UDF. So it will take a class label, right? Then what we are going to do, we are just going to create our temp code, let's say, and it will have initially 0 0. This will represent the case for versicolor. Then I will start writing my condition if this dot lower equal to iris setosa. Okay, then what we are going to do in case of setosa, the first value is 1, other one is 0. So what we are going in temp code, at the 0 place we will set it as 1, right? And now if that is not the case, let me copy this here. If it is Virginica, okay, then in case of Virginica, what is for first value is 0 and second one is true 1, right? So we are going to do, we will keep second value as 1, right? And if it is neither of them, then we are not going to make any changes because it already is represented here. Okay, now we are just going to return this, return. Okay, now let's quickly test our function here. So I'm going to pass first class label as, let's say, setosa. Print, let me also print for quickly Virginica here, and then versicolor. Okay, so as you can see here, for setosa it is 1 0 as we discussed above. Then for Virginica also it is 0 1 as we discussed, and for third case versicolor we have 0 0. Now we have successfully created our Python function to encode, one hot encode the class label. Now we will learn how to convert them into Pyspark. So we will keep the same name but just attach UDF here. So inside functions we have a function by the name UDF. UDF takes in multiple value in which first one is the function, Python function, which we are going to convert, right? Then second parameter here is the data type of the value being returned. Okay, so as you can see here, let me also print that out. Type of the value being returned. So as you can see here, the value being returned here is a list, that is an array, right? So we have to specify the type of the value being returned. So we will write here under t dot we have array type. Okay, so that is okay, we defined, okay, the object being returned is of type array, right? But inside array also, if you look at here, if I pick out the first value inside the array, also the type of the values inside the array is of integer type. So here also we will also have to specify what kind of values, what is the data type of the values inside this array. So inside this we will specify t dot integer type. Okay, so we will provide both the information. First, the output from the function is of array type or list type, and the list contains values of integer type. Okay, so now this is set and done. Okay, it's successfully run. We created our Pyspark UDF function. Okay, we have created that. Now we will in here we will create a new column in our existing data set, which will be one hot values. Okay. So with column takes in two parameter. First is the column name. So I've already provided that in string. Second is the values to be put inside that column. So what I'm going to do, so now I will use this function here, and this function takes in column values inside the column are class, right? These values will go here. So I will just type it out, class. Okay, so what we are doing, we are creating a new column. Column name will be one hot values, and what values we want to fill it with, we are going to fill it with one hot encoded values being written by this function. Okay, so let me show the results here. Since it contains 150 records, so let me put more there. Okay, meanwhile it is executing. Here we learned how to use it directly, right, as a Pyspark function. But what if we want to use it inside our SQL queries? So we'll come to that later. As you can see, for Setosa we have 10 values. For versicolor, as we discussed above, we have 00. Then for Virginica we have 01. Okay, so we got the required output. Now we are also going to create a register this function. Here we created here, create that for also Hive or SQL queries. So it has similar, way of doing, but only small changes. First, the Spark context here, we also need to create a SQL context here. So from Pyspark dot SQL dot just import SQL context. Okay, because we require SQL context to register temp tables or register Pyspark functions. So I've imported that. After this, I will create a context object. So inside this, we need to pass the, as you can see here, Spark context, right? So how we are going to get Spark context? We can get it from this Spark session object. Spark context. Okay, so let me create this. So we have the SQL context here, which we are going to use to register our register function. Okay, to register our this function we created above, this one, as a SQL or Hive function. So I'm going to copy this all stuff because this will remain same. So the first parameter inside register function is the name of the function. So I'm going to keep the same name. Let me copy it up from here only. So this was the name of the new function we created, right? One hot encode UDF. It is going to be same here. This is the first parameter. Second, as you can see here, the first parameter is the name. Second is the function, Python function. Then third is the return type. Okay, so we know the function or Python function is the one hot encode. We are going to put it in the second parameter. Third is this entire. Okay, so it is the return type, data type of the object getting returned from this function. So I'm going to run it. So this means that it successfully got executed. Now what I'm going to do, I'm going to also register my data frame as temp table and will name it data only. Okay, now we are going to write our SQL query. We can use SQL context, SQL. So I'm going to write my query here, select star. We will keep all the columns along with it. How we are going to use this function now? Simple. We are going to you pass it, use it as a function, passed inside it, pass the column name class. Okay, and now as one hot SQL, so we are naming the output from this as one hot SQL. Here in above scenario we named it as one hot values, but now we are going to name it as one hot SQL so that we know the output is coming from SQL statement. And simple from, we are going to use this table. So I'm going to assign it to object variable SQL output. Now we are going to show the records. So it will not take, shouldn't take much time. Okay, so meanwhile we are doing that. So as you can see here, we got these values as we expected, but these values are inside only one column, right? But what if we want them to be separated? Like in one column we want all this first, of this list, all the value, first value of these list, and in another column the second value. What if we want to do that? So we have so we have a explode function in Pyspark using which we can accomplish that. But let's look at the results here first. So as you can see, we got the same result here using SQL. This was using Pyspark, this is using SQL. Then same results here for versicolor, then similarly for Virginica. So let's also look at how we can split these values into multiple columns. So we are going to use this on data frame. Now we are going to write select statement, and inside select we will make use of PosExplode, this function here. What it does, first let me put a column name there so we can visualize the results. So okay, so let me show. So what it will do, it will create like for this list here, it will create two separate columns for each of them. As you can see here, we got values split into multiple columns, right? As you can see here. Okay, so now we can store it into, store the results here into a data frame, and then let me do that. So column we will create, since our data does not have any unique key on which we can make the join, we will create one. We are going to import pyspark.sql.window, import window. Okay, what we are going to do, we are just simply going to row number dot over, we are going to just assign a unique ID to each of the rows there. So that is we will use window function. Okay, so I'll just order by randomly on, let's say, class level only. Okay, that's it. Now let me also show the results. 5 false. Oh, so it should be there in a just, yep. So we got unique ID for each of those records. So in select, what we will do, we will also select the ID column here, exploded values, let's name it. Let's name it exploded values, and let me show the results. 5. Okay, Now in the end we are going to merge these two data sets. So dot join. So as you can see, we got the ID column and the exploded values here. Right now I'm going to merge it back on which column we are going to join. ID column, how we are going to join inner. So that is all. Let's show display 10 records. Okay, something went wrong. Okay, so I have to mention the keyword argument. Now what it will do, it will pick this data frame and merge it back here on ID. So it will take a while. It will run all the operations from the beginning. So what kind of output we will get? We will get two new columns here. One will have the first value from all these records, and second column will have second value, as you can see here. Okay, so that is all for this video. So quick recall, we learned how to create a Python function first to one hot encode the class label. Then we converted that function into Pyspark function here using UDF function. Then we also converted that Python function into SQL or high function, so we can use them in SQL queries like this one here. And then we also learned how to explode a array here, as you can see here, into multiple columns like these. And we also learned how if we have to merge it back with the original data set, how can we do that? Since we lacked the unique key, we did not have anything like that. We created one for ourselves. We just create a row number which will assign a unique number starting from 1 to each of the record. Then we also selected that unique record here in select statement, and then merge the two data set on ID, and we got our one hot encoded value split across multiple columns. So that is all for today. Hope you are learning from these videos, and please subscribe to my channel, and please like all my videos, and leave share the feedback, or if you want to learn anything specific in the comment box. Thank you so much, guys. See you soon. Bye bye.